on to question number 2 of this FRQ. I have it set up as 2 pages. As you can see, we've got A through F for the 10 points for this question number 2. Probably on an AP exam, this would span at least 4 pages. So you'd have a lot more room to write on these things. They give us a reaction, one that you should be acquainted with. We've got some carbonates, sodiums, carbon dioxide, and water. Decomposes on heating to produce sodium carbonate and 2 gaseous products. They give us the equation. Now, here's the question. A student claims that the reaction is an oxidation reduction reaction because the oxidation number of carbon changes. Do you agree with the claim? And your answer include the oxidation number of carbon in each of the 3 carbon-containing species in the reaction. Okay, oxidation numbers. Here we go. I've rewritten the equation so I can put the oxidation numbers down because we have to include them. Now I notice that here we've got a carbonate and another carbonate, and we've got our carbon dioxide. Those are the 3 things we need to deal with. We know that the carbonate has a charge of -2. And here it's still a carbonate again. It's got a charge of -2 also. So, I mean, you could say, okay, we've got sodium with a +1 and hydrogen with a +1 and 2 +1s, but either way, whichever is faster for you. And we know the carbon dioxide is going to add up to a 0. It's a neutral molecule. So we have to find the oxidation number of carbon in each one of these things. And we see that it's combined with oxygens, and unless oxygen is in a peroxide or with fluorine, the only substance more electronegative than oxygen, you know it's going to have a oxidation number of -2 in each one of these things. And here, -2 for the oxygens. Well, we have 2 of them, so therefore the oxygen, 2 times -2 is -4. We're adding up to 0 and +4. So our carbon on this carbon dioxide is a +4. And again, 2 and 3 gives us a -6. But now we have to add up to a -2 that you would have remembered for carbonate, or realize that we had 2 +1s for the sodium. So the carbon in this carbonate is +4, the same as the others. And we've got the carbon in the sodium carbonate with a +4. You'd say, hey, this is still a carbonate. There's going to be no change. It's going to be +4 too if you wanted to go quickly, or if you needed to do the numbers, and there. So we very quickly have determined the oxidation numbers of the 3 carbons, and we can answer the question. Now, my guess on this question, students got this wrong. They had no idea of oxidation numbers, or they didn't answer the question. That's one of the big problems. So look, do you agree with the claim? Okay, our answer should be no. We don't agree with the claim. The claim was there was oxidation reduction because the carbon changes. It doesn't. So answer, say no. If you don't say no and just have these oxidation numbers here, you lose the point. The oxidation number of carbon is +4 in each of the 3 carbon-containing species. Now, the answer no should have been here. And you could have just had the numbers up here, and the grader would accept that because he would see the oxidation numbers there. But still, I think it's a good idea to answer the question directly. The oxidation number of the carbon is +4 in each of the 3 carbon-containing species. So, do we agree with the claim? No. Include the oxidation number of carbon in each of the species. We've written that, and you've got a point. Okay, on to the next part, B.